In this video, I'm going to teach you how to name ionic compounds that contain polyatomic ions. I'd like for you to get out your polyatomic ion sheet, and at this point, you should have memorized most of these polyatomic ions. Now, I want to use phosphate, and I want to use this to provide a bit of an explanation to this structure and this idea of polyatomic ions. This is a Lewis structure, and what it is showing is 1 phosphorus and 4 oxygen that collectively, as a unit, carry an overall charge of 3-. That's important to understand as we move forward with naming this particular type of ionic compound. Now, you're going to follow pretty much the same rules that you've been using in Nomenclature 1 and 2 for both fixed and multiple oxidation states. Your Georgia Standards of Excellence wants you to know this term, ternary compounds. Well, these are compounds composed of 3 different elements. And throughout the video, we're going to be naming primarily ternary compounds. You're probably familiar with that prefix from biology and, say, tertiary consumers. Next, we're going to I want you to just kind of understand a few things first before we get to a practice problem. When you're writing ionic compounds with more than 1 polyatomic ion, you're going to enclose the polyanion in parentheses and then use a subscript to denote the number of those polyatomic ion units. If you would get out your periodic table you've been using throughout the last 2 videos, we're going to use the same set of rules. Number 1, you're going to name the cation followed by the polyatomic ion in this case. Next, if the cation or the metal has multiple oxidation states, you're going to be using Roman numerals to denote the charge of the cation. Not the number of atoms of the metal, but the charge of the metal. And now we can look at an example problem. Ostensibly, this ternary structure looks very complicated and perhaps even overwhelming. Well, I'm going to teach you how to name this compound with what you already know. I'm going to stick with the same polyatomic ion since I provided a brief explanation. Here's phosphate, and here's our structure. Well, first, let's look at the cation. The cation is magnesium. It's a group 2 metal. It's an alkali earth metal. Okay, so if it's an alkaline earth metal, we know something about this group, don't we? We know that this group all has a charge of +2. In other words, this is a fixed oxidation state, and we will not be using Roman numerals at all, because magnesium exists as a +2 charge. So we know each magnesium has a charge of +2. Well, if we name the cation, and we know we don't need Roman numerals, we can start by saying magnesium. Then we're going to say the name of the polyatomic ion, which we know because we know our polyatomic ions, right? That's phosphate, magnesium phosphate. That is the name for this ternary compound, magnesium phosphate. Now, using this same example, I want to provide an explanation for taking this form, this word form, and looking at it as a formula. So remember, the charges in the compound must balance. I've done that extensively in Nomenclature 1 and 2. So here's our name, magnesium phosphate. And you've already seen what the formula looks like. I'm going to explain how to get to that. So we know magnesium exists in a +2 oxidation state, single fixed oxidation state. And we know phosphate is a polyatomic ion that carries an overall charge of -3. So using this representation to help you understand, magnesium +2, which I need to say is correctly written as such for the cation. I am writing it like this to help you see how the charge is balanced. Let's do the same for phosphate. Let's start canceling them out. Well, that didn't work. I have a negative charge. I need another positive magnesium. So I can now cancel that. Well, that didn't work either because now I have a positive charge. Let me bring in another phosphate. And now I have a charge. I have 2 negative. Well, if I bring in a final magnesium and look at how these charges balance or cancel into an overall neutral ternary compound, I now have the correct structure for magnesium phosphate, showing 3 magnesium and 2 of the phosphate polyatomic ion units. And I'm using that term units because you will also need to be able to look at the atoms. So there are 3 atoms of magnesium. There are 2 atoms of phosphorus, but there are 2 times 4. So it's like the distributive property here. You would multiply 4 times 2. That's how many oxygen there are. There's 8 oxygen, okay? 8 oxygen total for this ternary structure. Now, you can always use the crisscross method, and you know what I'm going to say about this. Make sure you can explain to me why you're using it. Many students like this method. Some don't use it. My job is to teach you both methods and provide an opportunity for you to choose whichever one's most intuitive to you. So you would take the charge of the phosphate anion, and that would become the subscript for the cation. Likewise, the charge of the magnesium cation becomes the subscript for the polyanion, and you get the exact same structure as you can see here. All right, practice problems. Now let's go ahead and look at this structure, and I want you to start with what you know. Now in this case here, we have the charge, and we have a cation, and we're going to stop. We're going to look at the periodic table. Oh, here's iron. Oh, wow, it's one of the possible metals that exists in more than one oxidation state, which means I'm going to be using Roman numerals when naming this compound. So iron has more than one oxidation state. Roman numerals. Okay, now that I've established that, I'm going to look at the charges. They still need to balance, just as I went through in the last example. So start with what you know. Looking at this compound, I know iron has more than one oxidation state, but I don't know what it is. Sulfate. I know my polyatomic ions. Sulfate has a 2- charge. Okay, and I know that this is telling me there's 3 sulfates associated with this compound. So that means we can start going through and looking at balancing the charges. Okay, sulfate, which has here, let's see, 2- has a charge of 2-, and we have not 1, not 2, but 3 of them associated with this structure. We have 2 irons, but first let's find the charge of the anion. So there's 3 sulfates, each at -2. If I look at the overall charge, I get -6. Now I'm going to look at the fact there's only 2 iron. Now again, students will say, this is iron 2 sulfate. That's wrong. The Roman numerals do not denote the number of atoms of the metal. They simply denote the charge of that metal. Okay, so if there's 2 of them, 6 divided by 2 gives 3. That means each iron must have a +3, and they're metals, so they're going to be positive. They give away electrons. Now let's go through and do this. 1, 2. Okay, there we go. negative, positive, and boom, boom. Every positive canceled with the negatives. So now count the atoms. I count 2 iron and I count 3 sulfate, which is exactly what I would expect to find in a ternary compound called iron 3 phosphate or sulfate. Iron 3 sulfate. That is the correct name for this. Pay special attention to this 3 and the 3 used here. And now look back at the superscript of 2. This is not iron 2 sulfate. This is iron 3 sulfate. Okay? Again, you want to use the crisscross method? You can. You can use that, no problem at all. In this case here, the subscript of the anion, which is sulfate, is the charge of the metal, and the subscript of the cation ends up being the charge of the polyatomic ion, and that works, and it gives you the exact same formula. Okay? Now, I want you to come to me the next time I see you and tell me what these question marks means. I want you to know and come tell me how many atoms of iron, sulfur, and oxygen there are in this ternary compound. And we're going to talk about that to ensure your understanding. Now, the questions I will ask you in class, very similar to the ones you've seen in previous videos. Did you look at the periodic table? You don't want to make a careless error, so say yes, I did, because you did. And then, are both species to the right of the stairs? No, they're actually one's to the left, and the polyanions are to the right. That means this is an ionic compound. So no. And if it's an ionic compound, we need to know, well, does it exist as multiple oxidation states like iron, or is it fixed like magnesium, both used in this video? Answer could be yes or no. If the answer is no, then you say the cation and then you say the polyatomic ion. If the answer is yes, then you're using Roman numerals for the cation and then saying the name of the polyatomic ion. Let's do 2 more examples here. Ammonium hydroxide and, whoa, what is that? Well, we're going to start with what we know and work from there. Okay, first, ammonium hydroxide. Ammonium, as you know, is one of your polyatomic ions. In fact, it has a positive charge. So it kind of stands out. A lot of students know ammonium. Hydroxide, whoa, that's also a polyatomic ion with a -1 charge. Okay, can this exist? Yes, it can. We have a compound that has 2 polyatomic ions, and look at the charges. They cancel beautifully. Is it this simple? It is. This is ammonium hydroxide. Notice I did not use parentheses because there's only 1 ammonium and there's only 1 hydroxide. So there's no need to use parentheses to denote more than one of each polyatomic ion. Now, let's look at this other one here. Oh, that's nitrate. Nitrate's one of the polyatomic ions, and I know the charge is -1. And I also know there's 3 of them. So if I add the -1, -1, -1, it's an overall -3 charge for the anion. So there's 2, 3 total nitrate polyatomic ions. But there's nothing here. Please listen. This subscript does not apply to the cation, only the number of anions. So there's nothing here for chromium. Remember, that means 1. So there's only 1 chromium. And that 1 chromium must be +3. 1, 2, 3, because 1, 2, 3. And remember, I'm only showing chromium with those 3 pluses to help you visually understand, the correct way to show this is chromium 3 plus, but I'm just doing this to help you balance the charges. This is chromium 3 nitrate, where the 3 for the Roman numerals is denoting the charge of chromium. And of course, chromium is right down here. And I'm going to ask you, did you look at the periodic table? And when you say yes, and oh, it's a transition metal, you're using Roman numerals when naming this compound. So now we've continued to look at this Georgia Standards of Excellence, and now we've finally gotten to where we can write and name ternary compounds that contain polyatomic ions. And I'll see you guys in class.